This is the logger that we walked through in the last set of tutorial videos. And it's been out for a couple of weeks now, and we've already had some feedback from other instructors who really loved it and want to adopt it, but they found that they have more of a resource limitation in their classroom, in that they can't afford enough soldering irons for each student to have a full soldering station. And so the extra stuff that we added in this build, the soldering up here and the soldering down there, and the stuff underneath the board, these are actually problems in terms of their class structure. And so I took a few moments to think about this build and came up with a simplified one. Again, this is the same trick we used in 2016 to make the build faster. This is using Dupont connectors and jumper wires on the surface. And so if we turn this guy over, you can see that there's nothing on the bottom of the board. There's nothing that needs to be soldered. And so this is a sort of more minimal version for people who are either time or resource constrained and they still want to build the Cave Pearl classroom loggers. So let's take a look at putting that together. And I'm going to do this video in real time. I'm not going to do any cooking show tricks, just so that you can get a real sense of how long it takes to put the whole thing together. I'm really trying to aim at getting these builds under 2 hours so that it fits within a sort of typical classroom lab schedule. Alright, so the one part of this job that you still have to solder is the pin headers on the Arduino board. And I looked around and I couldn't find anybody selling pre-pinned Pro Mini equivalents that were affordable. You know, there's a few out there, but the price that people are asking for them is somewhat outrageous. And so, you know, even if you want to do sort of the minimum soldering version, there's really no way to get around, you know, attaching the pin headers. And so if you were limited in terms of the number of soldering stations you had per student, you probably would be best to just sort of pre-pin the boards. And there's a little bit of complicated soldering still in terms of dealing with the A4 and A5 pins, and I'll talk about alternative solution to that problem when we get there. Another reason why you might want to do this as the instructor for your course is that you can test the boards and make sure that they're functional. Again, I mentioned this in the earlier video, but basically before you do anything else, you want to get a UART on there and just make sure that the board is working, because there's a lot of these that are not really highly functional when they arrive. You get a lot of defects. So as before, I'm just going to kick off the limit resistors. I'm just going to assume you've done that test. So there's my first limit resistor for the LED on pin 13, and here's the next limit resistor for the power LED. Again, they're not highly useful from a data logging perspective. And this time around, we don't have to remove the reset switch because we're not putting the SD card on top of that. But I am going to suggest that we have to remove the voltage regulator. And the reason for that is that the voltage regulator not only wastes a lot of power, but if we want to get rid of the voltage divider underneath the screw terminal shield, the Arduino has the ability to read its rail voltage internally, so you don't need to add any extra components if the rail voltage is in fact your battery voltage. So that's what we're going to do. So I'm just going to clip that and kick it off. It doesn't take much to remove the regulator. And again, I'm going to do this in real time just so you get a sense of how long it takes to put this together. And I usually do the corners first. the other thing that we're going to skip in sort of this faster version is we're not going to repurpose the reset lines. So in the earlier tutorials we cut the reset pins or just didn't put them in, and we added some extra pins along the back, and we're just going to skip that here in this version just to make it faster. So, I mean, this is the speed that you kind of get to when you've had a chance to do a lot of these. We find that the students take much longer at this on their first try. It's like riding a bike. You know, soldering is just something you need to practice until you get a sense of the timing more than anything else. Okay, and you always need to clean them after doing some soldering. So just takes a moment here. Once you start doing a lot of these things, investing in a jewelry cleaner, you know, just a cheap one from the drugstore or Walmart or wherever, that can save you from having to do this step again in a group work situation where you're trying to get a lot of people processed quickly. It's probably worth the effort to go find a $15 cheapy ultrasonic jewelry cleaner to do this cleaning. All of these circuits are basically, as long as they're not powered, they don't really mind getting wet. Once you've got the resistors removed for the LEDs, the regulator is removed, the pin headers are attached, the last step is to deal with the I2C bus, which is the A4 and A5 pins. And what I do is I take the leg of a resistor and I just pop it in to the hole and bridge them across to these analog pins. Now A2 and A3 won't be usable for analog inputs. In fact, you'll have to be very careful when you do this that you don't turn them into output status digital pins. But it's worth the loss because it saves us from soldering the jumpers and all of the extra pins that we did on the previous builds. We're going to shortcut that process here by just taking the leg of a tinned resistor and jumpering those down to the side pins. If you want to be really careful about this one, you can cut the analog inputs, but because they're high impedance, they shouldn't interfere with the I2C bus at all. So there's one, and again you just sort of fold it down here and tack it over. It's just jumpering to the pin. The pin's already covered with solder, so this should be pretty easy to do. Alright, so there's one. It's the next one in the game here. Oh. You can move the resistor around as long as the solder's warm there and still end up with a good job of it. Okay. So that's bridged. And so what we've done is we've just basically broken out the I2C bus in such a way that it's accessible on the screw terminal shield. And that just saves us a lot of extra effort later. So the last step is to just go and take a look under the board here and trim away the tails, if you still have them, of those resistors left lying around. You don't want those to accidentally make a contact somewhere. They shouldn't, but this is the final stage for the Pro Mini board. Maybe doing a little bit more cleaning if you want to, but the nice thing about this is that now we've got access to our bus and we don't have to do any further jumpers. Again, these are optional. We're not going to use them on this build, but that's the completed Pro Mini. So the next step in the fast build is to use one of these pre-made boards, and generally they arrive pretty clean, but sometimes you find ones that have got some solder flux still on them, so it's worth taking a moment just to make sure that the pins at the bottom are sorted. We're not going to be soldering to the boards, but you know, you can never make your equipment clean enough. However, in a classroom situation where the loggers don't have to last for years and years, maybe you could just skip that. So the next step is to put some tape on these guys. And since we're not soldering, it's really relatively quick. Basically, just throw some tape along the edge there. And I would say use 3 layers just to make sure it's going to stick without running into the pins. I find the pins on these boards are a little bit longer than the ones on the boards you put together yourself, and so the tape needs to be a little longer to extend past them. don't throw away your residual tape. You'll be using that on the RTC later. Okay, so that's all we really need to do to the bottom. The next step is to bring in the Pro Mini that we just prepared. And again, you want to make sure you got your RX and TX pins aligned. So that's over here by the UART connectors. There's the RX and TX. And if you get the pins aligned, again, the digital side of the board, the labels match. Won't match on the analog side, and again, we've repurposed some of the analog pins to deal with the I2C bus. But if you get the alignment correct, and you want to make sure that you're sort of applying a gentle, even pressure to get it on. There we are. So at this point, we're not jumpering to these unused pins, and we're going to put the SD board on there. So I'm just going to chop those excess pins away. And this is a little bit tricky, but not overly so. The plastic usually comes away pretty easily. And then you just have to trim the pins, which of course fly all over the place, just like that. Doesn't have to be an overly neat job. Just want to make sure that you don't accidentally cut into the pins that the Pro Mini is attached to. So once those are cut away, that gives us a surface for the SD card to be attached to. So let's move on. All right, the next part is the SD board, and as before, we still need to remove the excess resistors on these boards. But we're going to save a lot of time by not soldering to the pins. We're just going to use some of these pre-made Dupont connectors with a cable shroud and just make a connector that goes right in. And again, this is exactly what we did in 2016 with the previous builds. So first you need to kick the resistors off. Again, if you're preparing stuff for a classroom situation, you probably want to do this before you hand the components to the students, but it doesn't take very long. It's really not a complicated procedure. Just like most of the components, there's almost always excess resistors that you don't need. Okay, so another thing is, of course, always clean. Just about everything needs cleaning. Depends on how long you expect the run to be. If you're only going to be using a logger in a classroom for a couple of weeks, you probably don't need to worry so much about the scrupulous cleaning, but okay, so there's our adapter, and we need a couple of cables off of this pre-made Dupont. I'm just going to pull those off and get them ready. So we need a red and a brown and an orange and a purple. There's a purple. And gray. Where's the gray? There we are. There's the gray. So again, I'm just stripping them off of these pre-made DuPonts, and then we can just insert them into the cable so they're ready to go. And it couldn't be easier. Basically just one. And I'm using a color scheme here that matches the previous tutorials. There's nothing special about these colors, they were just the ones that I happened to use the first time I did a logger, and so I've just been consistent so that when other people follow these tutorials they all use the same colors for the MISO, MOSI, basically for the SPI bus. But once we're at this point, we can just plug this cable in here. Okay, and there's our connection to the card module. We're just going to put a little bit of tape on that, and then we can plug it in place on the screw terminal shield that we just trimmed. So here's some of that excess tape that we had earlier. Just a little length across. Alright, so this is where the fun begins, because now we're going to put the SD card module just on the back side where we cleared the area, and we'll start making the connections to the Pro Mini itself for the SD card. And you want to put the tape so that it covers both the module and the Dupont connector, because then it holds them together. So they'll be held in place fairly firmly. Right. So there we are. That's the SD module in place. So now we trim these wires and bring them over to the right order of connection on this board. We'll be bringing the SPI bus, which is the four center wires, over here to what's on the board labeled as A1 to A3. Those are of course incorrect, because this, remember, this is a board for a Nano, not for a Pro Mini. This is actually pins 10, 11, 12, and 13 along the edge of our Pro Mini. So the connection order is, first we will deal with the gray wire. It goes to A0, and these are the three unused pins. So you just fold it over and cut it so that it goes nicely into the screw terminal without having too much excess. And strip the wire. Again, you want to be careful that you don't accidentally take too much off, so make sure you don't misjudge your wire stripping. We're going to be attaching a lot to this side of the board, so I'll just open up all of these. Next one is orange. With these single Dupont wires, they're pretty thin. I think they're either 28 or 30 AWG, and that means that you have to tighten the screw terminals down pretty tight to make a good connection, because the wires are really quite thin. For the purpose of the SPI bus, it's probably better because it means there's less capacitance, but it means there isn't a whole lot of copper here. Okay, so gray, orange, purple. Okay, so that's the 4 lines of the SPI bus that is used to communicate with the SD card of this logger. And now we're going to bring the power lines over, and that's going to be a bit more complicated because we're going to have to add some jumpers. Because we're not doing any soldering on the bottom side of the board, we're going to jumper these power lines back over and use the far corner just simply as connections to bring the power into the logger. So the most complicated, these are really the most complicated ones. We're going to try and put multiple wires under each one of these terminals, but because these wires are so thin, that's actually pretty easy to do. And we're also going to add a couple of extra jumpers out to the breadboard, again from these power lines here. So this one, now that we're at this stage, we've got to get some extra wires to do that attachment. Alright, so we'll do the power line first, because that's the most complicated one. And again, we're just bringing this over to what's labeled as the 5-volt rail. It's not actually 5 volts on the Pro Mini, but it's labeled that way because this is the board for a Nano. So we'll bring the 5-volt line over. And to that, we're going to be adding 3 extra wires. A tiny jumper that literally just goes from 5 volts to V in. Another one that wraps around the board and ends up attaching down here to bring the power in, and one with a male connector on the end of it, so we can actually reuse one of these Dupont cables here. So I'm just going to cut a red wire from here just to save us time again from the perspective of the fastest build you can do. So this jumper is just going to go from the power line over to the breadboard so that we can power our sensors. So to put them all together, just strip the wires, and I usually put some heat shrink around these because these tend to pull apart. You don't want to put any stress on the wires unnecessarily, and so I'm going to put them together as a bundle once they're stripped. You want to do this a little bit carefully, make sure that they're all exactly the same length at the end of the bundle. Okay, and I'll twist them together here. I'm going to slip a little bit of heat shrink on there, again, just to hold this bundle as close to perfect as I can get it. So that stress on one of the wires doesn't pull it out of the screw terminal. I'll give it a little trim just so it fits really well into the screw terminal adapter. Alright, so there's 3 extra jump bar wires added to the VCC line. And these are all well secured now. The shortest of these is going to jump over here, so I can put that in place now. We're actually going to bring the RTC line up to that later. But for now, what it's really doing is, if I join the rail to this V-in line, what I do is I'm recruiting this other capacitor. This capacitor is now an orphan because we removed the regulator, and so we can bring that into play to help stabilize the system voltage just by making this jumper. So it serves 2 purposes really. Gives us a power point for the RTC later, and it brings that capacitor into play. Alright, so this one's going to jump over, the one with the male end on it, it's going to jump over to the breadboard, but this one is going to come over and is just going to act as a power connection for the battery later, and we're just going to use these unpopulated screw terminals as a connector for that. And I like to use slightly thicker wires for this power jump. It probably doesn't make that much difference for such a short distance, but I don't want any voltage drops on the power that we're bringing in. So this is a 22 AWG silicon wire. Okay, so there's the power wire with our jump over to the breadboard. Sorted out. Now we're going to do the same thing with the ground line. The ground line will get 1 less wire under the bundle because we don't have to jump over to the to recruit that extra capacitor. And again, I've just found over the years that when you put the multi-wire connections under a screw terminal, it helps to have a little strain relief just outside of the screw terminal. Left that a little bit long. Alright, so there's the power lines from the SD board also over to some jumpers, and then the last step is to bring this down as a power connection over here. Alright, so that's really probably the most complicated part of the Dupont jumper build. So that board is ready to put into the housing now. Preparing the RTC board, again, just as I'm sure everyone's used to by now, we kick off a few unnecessary resistors. This is the charging circuit that we don't use, and this is the power LED, which just wastes power but does nothing. So this part could be done before you hand the components out to your students. Also the cleaning, again, I'm just going to zip past that here, but I clean these things pretty ruthlessly when I'm putting them together for something that's going to be deployed. We're going to first put a little bit of tape across the chips here, and then we're going to make another Dupont connector, just as we did for the SD card. We're going to take some of these raw Dupont cables and we're going to put them in a shroud, and then that allows us to connect the RTC. So the scrap tape that we had from taping the board works really well for this, because you've already got it cut and you're just one layer over the small chip, and then another layer goes across both of them. This is just for leveling this first piece. Okay. Alright, so now let's make a cable. And we'll need a red, a black, a white, a yellow, and a blue. And they tend to be pretty close to each other on these cables, so you don't need to, you end up with about half a cable left after you've built one of these loggers. So you really only need sort of one cable for two loggers. I always use white for my data on the I2C bus, and yellow for the clock, and blue for the interrupt. And so the pattern is black goes in first, and then red, white. You can hear them click. If you've got the right shrouds for the cables you're using, you know, they sort of make a little popping noise when they go in. Alright. And the last row here, if we flip these over, that's the 32K line, which we're not using on this logger, but I like to use a shroud that has the possibility, because later on you could just come in and plug something in and not have to worry about it. But once you're there, you just push it into place, and we're going to put another little bit of tape there so that we can attach this to the housing. Okay, so we have tape. We have the connector made as a Dupont connector, and of course we need to put a battery in there too. Alright, so now we have the RTC module ready to go into the housing. And once we've got the main board and the RTC, we just have to throw a little bit of double-sided tape onto our battery holder. There's already some tape on the board, on the breadboard, so really you can just put a line along the bottom here. Alright, and we've got, you know, the four main components ready to put into the housing. With our components ready, this part of the process goes pretty quick. I usually start with our SD card Pro Mini screw terminal stack, and we've already got the tape on there, so this is really just a matter of peeling the backing off and putting it in place. Okay. So I try and leave myself just enough room so that I can get into those screw terminals later. You don't want to be squishing everything, but again, you also don't want to leave just tons of space, because you've got to have room for the RTC. So kind of just try and put it where I know I'll be able to get my tweezers in there and access these screw terminals if I have to. Alright, so there's the Pro Mini, and this fella has to be located where these jumpers can reach him, so sometimes it's a good idea to just put those in place and make sure that you don't position this so far away that you can't get to it. So because these lines are actually a little bit shorter than I'd like, I just used what I had. We should really have used a 20 centimeter so that there was lots of excess here, but I only used a 10 centimeter Dupont cable, so that's a little bit short, and that's going to make me put the breadboard a little bit closer than I normally would, just so that I can make sure that I have access to these two lines here. Again, I just did this for the purpose of demonstration. Normally I would use longer wires. Okay. And I'll put the RTC in. So I usually put the RTC sort of right against the wall, again leaving room along these screw terminals so that nothing interferes once it's in place. And you can even push this connector down a bit so it's got a full, all of the surface area is in contact. There we are. Now the next thing we're going to do is bring the power and the two I2C bus lines up here. And as we did with the ground and the rail, we're going to actually add a couple of extra jumpers to bring the I2C bus over to the breadboard. So again, I'll just cut a white and a yellow here. And those are going to be our jumpers over to the breadboard. And I'll start with the power line. And the power line is going to actually connect to this V-in jumper right here. So I probably cut this longer than it needed to be, but it's just easier to work with your fingers if your jumpers are perhaps a little long. You can always use a zip tie to clean things up later. Okay, so there's the RTC power rail. Next we'll bring up the clock line. And I'm just doing this by eye. Just push it out to the edge, right down, cut it to length. Okay, so there's the extension that'll go to the breadboard. And I find it's worth the effort to kind of route these as neatly as you can. Oops. I squished the wire there, it didn't quite go in properly. So I'm not getting a good enough grip on them with these tweezers, so I'm going to get a pair of pliers. So now it's in the terminal. Give it a little tug to make sure it's nice and secure. Basically repeat the process with the data line. Probably should have put some heat shrink on there just for strain relief. Again, I did that with these larger multi, but I probably should have put a couple of little bits of heat shrink on there as well, just to make that a bit stronger. But this is just a quick build demo here. So from the RTC, that's the two I2C bus lines and the power, the VCC line, brought up to the top and then jumpered across to the breadboard so that those connections are available for sensors. The next two are simply the ground and the interrupt line, and because we've got a ground pin right here, all we have to do is bring that wire literally to there. Alright, so there's the ground line attached, and the interrupt from the RTC is D2, which is literally right beside it. quite seem to go in as much as I'd like, so I'll give it another tighten. Alright, so that's the remaining two connections for the RTC module done. The last thing we have to do is add the battery holder. I usually place the battery holder to give as much room as possible around the breadboard, because this isn't going to expand, but you might have a screen or something that, you know, that little bit of extra space might actually matter up there, but it doesn't matter to the battery holder very much. And these battery connections are literally just going to go to these jumpers that we brought down when we were putting the power on the SD card, so they just go here and get cut. And you see how I'm folding that down a little. You know, experience tells me always leave yourself some extra cable. If it doesn't hurt the design or the build in any way, give yourself the opportunity to repair a mistake by leaving a little bit of extra cable before you trim. Since we have the opportunity now, I'm going to pull these jumpers out. I'm going to actually tuck them more neatly under the SD card wiring, just to keep them out of harm's way. Okay, so that's the two power rails, and again I just trimmed them so that they're the right length to go under the screw terminal. Okay, so there's the battery connector. Again, trim it to length. Always give everything a little tug to make sure it's secure, especially these multis where you're actually using the screw terminal as a connector rather than as a link to the Pro Mini. Okay, so that's all of the basic wiring of the logger in place, using the screw terminal boards as connectors to make all the joints. So we didn't have to solder anything, we just made these Dupont connectors and we linked them on. The last thing is adding an indicator LED. And if you're in a hurry, or if you're in a classroom situation, you can buy these little 50/50 boards, and they already have limit resistors in them, so that saves you the time of soldering. And if you just bend the pins slightly, you can pop it right in to the screw terminals. And I'm going to attach it here to D3 to D6. There's a ground pin on one side. On the left hand side of this board is a pin that has to sync the current, so you'll have to turn one of the pins you're connecting this board to an output low. But if you do that, then the other pins can each drive one of the colors on the LED. I don't use these boards very often. They're not that expensive, but you know, compared to an LED, which is pennies, I think they usually end up charging about 50 cents for one of these boards. But in terms of getting an indicator LED onto your logger as fast as possible in a classroom situation, which, you know, one of the most common errors is forgetting to put a limit resistor on. You can't do that with these boards because the limit resistor is already there. So there's a limit resistor set already tuned on that 50/50. So there's your final step for the completed logger. That's as it functions right now. It's fully functional, and with two lithium LEDs. This is one of the limitations of this method. Because we didn't want to put the voltage divider underneath, we have to use lithium batteries, because lithium batteries have a really flat discharge curve and they'll stay above the minimum routing voltage on the Arduino and the SD card for a very long time before they go flat with only two batteries. So you want to use lithiums if you're going to do this kind of build, and it saves you from having to solder a voltage divider. The other thing that you can do from here is add a couple of sensors. And so the RTC, the code that comes with the logger, already records temperature. There's a temperature sensor in the RTC. And you notice that on this build I didn't put holes in the housing. That was because I'm assuming that the sort of sensors you're going to use if you're in a hurry are the kind that you can just plug in, and so probably the easiest one to do would be the something like this analog light sensor. These little CDS cells cost nothing, and so it would be dead easy to just hook up a voltage divider between the rails, which we've already brought over, and jump. We've only got two analog lines left here, A0 and A1, but we can just make a quick jumper here. Alright, so there's the analog input jumper, and if I simply set up a voltage divider with a 10K resistor and one of these little CDS photosensors, which maybe cost 10 cents each. It's not the prettiest one I've ever done, but basically that's a voltage divider that will sense light. There's already a temperature sensor in the RTC, and the code, the demo code that we've released, already reads A0 and records the temperature. And so you close that up, and right there what you have is a logger that will read temperature and ambient light, because the light sensor will read right through the housing. So there we are. We've just built a fully functional data logger in how many minutes, and we did very little soldering except for the Pro Mini board, which again, if you're the instructor for a course that you're trying to get this all to be done quickly, you could probably do all of that soldering on the boards before you hand out the parts. So there we are. There's the Dupont connectors version of the Cave Pro classroom logger. Not bad for the fastest build. Again, I probably, in hindsight, I think I would have made these cables a little bit longer. All I had on the shelf here was a 10 centimeter male Dupont. But if you bought this long one with male at one end and female at the other end, it would give you all the connectors that you need to stretch this out over to the other side of the board. But there we are, the fastest logger in the West, I think. Oh yeah, one more thing I forgot to mention. This logger, as we've built it, should sleep somewhere between 0.18 and 0.19 milliamp with the SD card in tow. However, if you wanted to do a longer lasting build, you can pop the RTC off and do the RTC power mod that I described in the tutorial post, which is basically just getting into this VCC pin on the DS3231 RTC. That's the second pin in, and you just carefully lift that or cut it, and it forces the RTC to run entirely from the backup battery. And since the RTC is pulling about 0.08 milliamp all the time from the main logger, if you do that, the logger will run at about 0.1 milliamp sleep current, which is not bad. You should easily get more than a year out of a couple of lithium AA's with the whole logger sleeping around 0.1. It does limit your lifespan to however long the CR2032 battery can supply wake-up alarms. But that should easily get you a couple of years as well. So again, if you have new cells, new clock battery, and new lithiums, you can pull this logger down to 0.1 and easily get a couple of years out of it. The other thing I wanted to mention is, I didn't mean to imply that this was only good for sensors that can operate inside the housing, like an accelerometer or something like that. If you take an old soldering tip, and you want it to be an old one because this ruins the tip, so find one that's already ruined. The tips will go through these housings like a hot knife through butter. So if you need to use this logger with a sensor that requires air exchange, like say a BME 280, which does temperature, pressure, and RH, you'd just pop in some holes into the housing here along the side to allow air exchange, so that the sensors that are on the inside can read those barometric signals or something like that. So again, even if you don't have a drill in your class, just find an old tip and you can just pop holes into this low-density polyethylene housing very easily. Just try and avoid the area near the O-ring, because you don't want to make it hard for the logger itself to close. But yeah, perfectly easy to adapt this. Maybe a few holes along here as well, so that you can use sensors that need contact with the outside environment. Okay, there we go.